radioactive decay. So example, polonium-210 have a half-life of 140 days. Suppose a sample of the substance have a mass of 300 grams. Find the exponential function in the two forms that model the remaining mass after T day. Okay. So let's start with this. So what we are given, we know that half-life is 140 days. So we're given T equal 140. Excuse me. We're given H equal 140. And we given the mass is 300 milligrams. So N naught equal 300 milligrams. So to use the formula, M of T equal M naught times e to the negative RT, we need to figure out what is R. Well, we know that R equal ln of 2 divided by 8. So what I do to avoid the rounding error in the previous section, as you can see, I just leave it as ln of 2 divided by 140. With this information, I get M of T is equal to 300 times e to the negative ln of 2 divided by 140 times T. That's part A. And the other formula, N of T is equal 300 times 2 to the negative T divided by 140. In part A, we want to find the mass remaining after 1 year. Okay, after 1 year. So let's assume that T equals 365 days. That is 1 year. So first formula, M of 365 equal 300 times e to the negative ln of 2 divided by 140 times 365, and that is and that is 49 days, rounded to the whole days of 2 grams. So 49.24, let's make it 2 decimal places. So that is 49.24 milligram left after a year. Let's see what happened with the second formula. N of 365 is equal 300 times e to the negative 365 divided by 140. And that is the same. So 49.24 milligram after the whole year. Okay. So what do you know about the result? Well, they are the same. So part C, how long will it take for the sample to decay to the mass of 200 milligrams. So we want to calculate T for N of T equal 200. Okay. So I go ahead and use the second formula. So 200 equal the initial one times 2 to the exponent negative T divided by 140. So 2/3 equal 2 to the negative T divided by 140. So log of 2/3 is equal to negative T divided by 140 times log of 2. So T is equal negative 140 log of 2/3 divided by log of 2. And that is okay. So that is about after 82 days. And you can use the graphing calculator to go ahead and sketch the graph of the function. Let's talk about Newton's law of cooling. If D0 is the initial temperature, the temperature difference between an object and its surrounding, and if its surrounding have temperature T sub s, then the temperature of the object as time T is modeled by the given function, where K is the positive constant that depends on the type of object. Newton's law of cooling is used in homicide investigation to determine the time of death. A normal body temperature is 98.6 degrees Fahrenheit. Immediately following death, the body begins to cool. It has been determined by experiment that the constant in Newton's law of cooling is approximately K equal 0.1947, and this constant is different for different types of objects. Assuming that the time is measured in hours, suppose the temperature of the surrounding is 60 degrees F. Find a function T that models the temperature at temperature T hour after death. Okay, so in this case, what do we know? We know that the normal body temperature is 86.6 degrees. Okay, and we know that the temperature of the surrounding is 60 degrees F. This means the initial temperature difference is equal to 98.6 minus 60, that is 38.6 degrees in this case. We know K, okay, and the surrounding temperature is Ts, so Ts equals 60 degrees. So with this, I can write a formula that is equal to okay, so here's part A. Part B. If the temperature of the body now is 72 degrees, how long ago was the time of death? So now 72 is equal to 60. And we need to find T. And that is so the body been there for 6 hours.